Three friends share a perfectly circular pie. By making three random radial cuts from circumference inward to the center, what is the probability that no friend receives more than half the pie for his or her share? This is a problem that will illustrate the concept of geometric probability, and it's such a fun, challenging problem. So let me start by this circular representation of the pie that we're trying to divide up. And let's try to see, first of all, how the division is made, and at the same time, basically figure out what it takes so that no single division exceeds half the pie or half the circle. So from now on, I'll be basically referring to the pie as a circle, just for clarity. So if we have one radial cut like this, right? So we are basically going from circumference inward to the center, and then we can make another radial cut, and that is basically going to define a sector of the circle. So that's one piece, right? Now, of course, the cuts are random, so this particular cut could be anywhere, right? But let's constrain it in such a way that the division doesn't exceed half the pie, because that's kind of the interest in the problem, right? So no friend should receive more than half the circle. So this cut could be here, right? Or in the limiting case, it could go right up to here. And this is basically, making that particular piece equal to half the circle. Now we have the requirement here that it shouldn't exceed half the circle, right? And the angle, the sector angle, this is tracing out, is actually 180 degrees or pi radians. So now if we get back to this particular cut, and since this is random, let's just represent the sector angle by theta, right? And since we are considering here the special case that no division should exceed half the circle, so theta should be constrained between 0 and pi radians, right? Because if it exceeds pi radians, then that means that particular division is now exceeding half the circle. Now we have to consider the third radial cut. So the third radial cut, that will basically define the second sector and the third sector simultaneously, right? Because whatever we are left with after that cut will be basically the third sector, the third piece of the circle. So let that cut be like this, and let's define the second sector angle as phi or phi. So that's the angle that I've traced out in green. So that's the second sector angle, which is made by this third radial cut. And this pretty much defines all three pieces of the circle, right? So for the same reasons that made us constrain theta between 0 and pi radians, phi or phi should also be constrained between 0 and pi. Now, another thing to note is, the sector angles theta and phi taken together, they should be more than or equal to pi radians. Why? Because if they are less than pi radians, that leaves the third piece to be greater than half the circle. So if the two sector angles theta and phi is basically less than pi radians, then the third piece that automatically becomes greater than half the circle, which makes that particular division greater than half the circle. So we need this third constraint. Basically, the first two sector angles, their sum taken together, should be greater than equal to pi radians. What it means is basically the first two sector angles taken together, they should exceed half the circle, so that the remaining piece that's left is less than half the circle. So that ensures that all the three divisions individually, they are less than half the circle. So this is a special case, right, for which we're considering here. So that's why I put it in red. Now let's consider the case where we have no restrictions. So then theta can go pretty much any value greater than 0, right? And so can phi or phi, that's the second sector angle. But taken together, their sum needs to be less than equal to 2 pi, because the whole circle is basically 2 pi radians. So the sum of the two sector angles couldn't possibly exceed 2 pi. So that's pretty simple, right? So now we have basically what's needed for calculating probability. We actually laid out the conditions, right? So we have laid out the special case first, where no division exceeds half the circle, and then we have basically laid out pretty much the entire sample space, where there are no restrictions on size of any one division. So now we graphically plot out, what these sample spaces mean, in terms of representation on the theta phi plane. So we draw the theta axis and the phi axis. So this is, just like drawing out x and y axis. The variables, instead of x and y, I've called them theta and phi just because they are sector angles, but it's basically the same principle as graphing in a 2D xy plane, right? So first let's consider the restriction-free division. So for that, we draw this line out, which represents this equation theta plus phi is equal to 2 pi, and that will meet the two axes, the theta axis and the phi axis, at 2 pi, 0 and 0, 2 pi. Those will be the coordinates of the points where this line cuts the theta axis and the phi axis respectively. So if that's the case, then I can say that without any restrictions, any point that lie within this triangle satisfy all those conditions that I have written down in black. So they basically satisfy theta greater than equal to 0, they satisfy phi greater than equal to 0, and they also satisfy theta plus phi being less than equal to 2 pi, because they are under the line, right? Under that straight line, theta plus phi equal to 2 pi. So this black triangle basically represents my all sets of possible divisions, all possible sector angles that I can have without any restrictions. So now we'll consider our special case, our requirement that no division should exceed more than half the circle. And for that, we'll draw those lines out in red here. So first draw this line, theta equal to pi. So this is a line that's going to be parallel to the phi axis, and it will basically intersect the theta axis at the point pi 0. And let's draw out another line phi equal to pi, and that will be parallel to the theta axis, and it will intersect the phi axis at the point 0 pi. And then these two lines will meet each other, and it will also intersect the line, the black slanted line that I've drawn, which is theta plus phi equal to 2 pi at this common point pi comma pi. So this is something that you can just cross-check or verify from simple, straight line equation and simple coordinate geometry. So I've still got to have the third representation for my special case, which is basically theta plus phi together needs to be greater than or equal to pi. For that, we draw the line theta plus phi equal to pi. And that can be drawn simply by joining these 2 points, 0 pi and pi 0. Because if you look at the equation of the line theta plus phi equal to pi, it meets the theta axis at pi 0. So if you set phi equal to 0, theta becomes pi. So that's the point where it meets the theta axis. And similarly, it meets the phi axis at the point 0 pi. So if you just join those 2 lines, you basically get this particular line, theta plus phi is equal to pi. And since for this special case of the no division exceeding half the circle, we need theta plus phi, the sum, to be greater than or equal to pi. So those points need to lie above this line. At the same time, the points need to satisfy theta less than or equal to pi and phi less than or equal to pi. So they need to lie, below these parallel lines, phi equal to pi, and basically to the right of the other parallel line, theta equal to pi. So basically they need to lie within that red triangle that has been formed by these 3 red lines, right? So for a special case to hold, those sample points or those sector angles, basically on the theta phi plane, they could be anywhere within that red triangle, but they need to lie within the red triangle. So that red triangle basically represents my set of points which will satisfy the condition that no division would exceed half the circle. And my black triangle, so that is all potential set of points without any restrictions on the size of any one division. So that has got basically all possible sector angles theta phi that I could have without any restrictions. So it's simple to see that the probability would be basically the area of the red triangle divided by the area of the black triangle. So what's the area of the red triangle? Well, that's just a right angle triangle, right? And the base of that red right angle triangle is pi. The altitude is pi, so it becomes half multiplied by pi, which makes it half pi square. And what's the area of the black triangle? Well, that's another right angle triangle with altitude 2 pi and base 2 pi. So that will be half multiplied by 2 pi multiplied by 2 pi, which makes it 2 pi square. And then you find the probability that no division exceeds half the circle by simply dividing these 2, right? And when you do that, the probability that we get is 1 by 4. So the probability that no division exceeds half the pi or half the circle is basically 1 by 4.